Welcome to The Explainer. I am so thrilled to have you here with us today. Look, we're standing at the edge of this completely unprecedented shift. The reality is pretty stark. The world of AI is moving faster right now than anything we've literally ever seen in human history. It's an incredible time to be alive, for sure, but it demands a massive, immediate shift in how we think, how we work, and most importantly, what we are actually building. We're way past simple chat interfaces now, right? We're getting deep into complex, multi-agent software architectures. So today, we're going to break down exactly how to build these next-gen systems using LangGraph's advanced features.
All right, here is what we are covering today. First, the AI revolution. Second, the power of prioritization. Third, we'll get into LangGraph subgraphs explained. And finally, number 4, the MapReduce pattern. Let's dive right in.
Section 1. The AI revolution and why the world is on fire.
So our source material issues a pretty blunt warning. It says, the world is on fire, AI will eat you alive. Now, I know that sounds super dramatic, but it's a completely necessary wake-up call. We are hurtling towards artificial general intelligence at just a breakneck pace. We're not talking about some slow, generational shift anymore. With the absolute velocity of these new model releases, traditional jobs, the kinds of roles people thought were totally secure, they're facing replacement. And not in decades. We're talking a matter of months to just a few years. Entire industries are about to be restructured from the ground up. Standing still? Yeah, that's just not an option anymore.
Because of this, we're seeing this massive divide in how people are responding. On one side, the old world is panicked. You've got bank tellers and, as the source points out, roughly 10 million truck drivers whose jobs are fundamentally threatened by incoming automation. The masses are kind of paralyzed, right? Just worrying about being replaced. But then, look at the new world focus. The pioneers actually building agentic AI, they aren't panicking at all. They're treating this like the ultimate land grab. These folks are dedicating 14 to 17 hours a day to mastering these technologies. Why? Because the first people to build reliable, scalable, multi-agent systems are going to capture the lion's share of the value. It's a completely different level of intensity, driven by the fact that we are literally rebuilding the infrastructure of the digital world.
Which brings us to Section 2, the power of prioritization, surviving the shift.
So let me ask you, do you know how to prioritize? There's this brilliant anecdote from our source about a young grad interviewing at Intel back when they were the undisputed #1 tech company in the world. The hiring manager didn't even bother asking him complex technical questions. Instead, he just looked at him and asked, "Do you know how to prioritize?" It took the speaker years to realize that this single ability is the ultimate deciding factor for success. And in the AI era, man, this is more true than ever before. Pure technical skill, just the ability to write syntax, is fast becoming a commodity because AI can just write that boilerplate code for you. But what AI cannot do is decide what is most important to build right now. Human prioritization is what directs the architecture. It's hands down the most critical survival skill you can develop today.
Think about it like this. If you're dropping your AI studies to go attend some distant relative's wedding, someone you barely even know, you're kind of losing the plot. To build world-changing AI and leave a lasting impact, you have to adopt a true innovator's mindset. The source literally calls it being a bit psycho, but in a good way. It means being obsessively dedicated to your craft, ruthlessly ignoring the everyday noise, and focusing entirely on creating value. Look, in a world where distractions are everywhere, the people who actually win will be the ones who can shut out the trivial stuff and dedicate their entire cognitive load to solving the hardest problems in front of them.
All right, let's get into the technical side in Section 3, LangGraph subgraphs explained, delegating complexity.
So what actually is a subgraph? To wrap our heads around this, we first need to understand why a standard linear graph just falls apart at scale. If you try to cram a complex AI workflow into a single massive graph, you end up with an unmanageable mess of conditional branches, and your context window just explodes with totally irrelevant information. LangGraph solves this by introducing subgraphs, a multi-agent architecture. Think of it like having a parent graph that acts as a highly efficient project manager. This manager has a massive, complex project, but instead of trying to do every single step alone, the parent graph delegates specific tasks to independent child graphs. These are like specialized employees who take their assignments, work on them simultaneously in parallel, and then just report back.
Let's walk through a concrete case study from our source material involving student grading logs so you can see exactly how this works in action. Okay, step 1. The parent graph receives a massive dump of raw student logs. Step 2, it hands that data over to child A. Now, child A is an agent specifically built with one prompt, to analyze why students failed. Step 3, running completely in parallel, it sends that exact same data to child B, an agent built only to summarize the questions students asked. Finally, step 4, both children finish their very specific jobs and return their updated states back to the parent. Just think about the compute and time savings here. If you ran these analyses sequentially, one after the other, it creates this massive bottleneck. But by executing in parallel, you maximize throughput and drastically cut down your system's overall latency.
Now, to make this multi-agent architecture work without it devolving into absolute chaos, LangGraph lets you strictly separate your states. And let me tell you why this is an absolute game changer for context window management. Your input state might contain 4 fields. You know, all the messy raw logs, full user data, timestamps, the whole shebang. But your output state from those child graphs might only contain 2 fields, just the clean, concise summaries and the specific IDs they processed. If the child graph shared the global state of the parent, your LLM's context window would instantly fill up with raw data garbage. And we all know what that leads to: hallucinations and massive API costs. By isolating the state, basically forcing the child to only return the pristine processed output, you prevent state bloat. It keeps your whole system perfectly clean and highly reliable.
Moving on to Section 4, the MapReduce pattern, parallel power.
Here is a huge question for you. What happens when you don't know how many tasks you actually have? With standard subgraphs, you're required to define the nodes and draw the edges, the pathways between tasks, ahead of time in your code. But imagine a scenario where the number of pathways is completely unpredictable. If you try to hard code this in a traditional setup, you end up writing these endless, brittle conditional statements. You know, if 2 tasks, do this, if 3, do that. Your code just becomes this fragile nightmare that breaks the very second a user asks for something even slightly outside your predefined parameters. For instance, imagine a user asks your AI to research a generic programming topic. That topic might logically break down into 2 subtopics, or 3, or maybe even 50. You have totally unpredictable subject counts at runtime. So it becomes literally impossible to pre-draw static graph edges because, well, you don't know how many child agents you actually need until the user hits enter on their prompt. You desperately need dynamic scaling. And conceptually, LangGraph handles this brilliantly using specific features like the Send API. Instead of returning a single static route, a node can return a dynamic list of tasks. This allows the framework to dynamically trigger multiple parallel edges at runtime based exactly on the data it just generated.
Let's break down this MapReduce solution using a really fun classroom analogy from the source. First, you have the map phase. You take that big, generic programming topic and dynamically divide it into whatever subtopics emerge. So let's say it determines Python, Java, and JavaScript are needed. Second, you enter the process phase, and honestly, this is the true superpower of this architecture. LangGraph dynamically spins up parallel teams for each of those subjects instantly. Let's say their task is to generate a joke about their specific language. You now have 3 specialized agents running simultaneously. Finally, you hit the reduce phase. You aggregate all those generated jokes together into one node and select the absolute best one to show the user. It divides the work, runs dynamic parallel teams on the fly, and then combines the results effortlessly. It's just so elegant.
So we've covered the psychological mindset required for this era, the elegant delegation of subgraphs, and the massive dynamic scaling power of the MapReduce pattern. But knowing all of this just isn't enough. Building these complex systems requires that exact ruthless prioritization we talked about earlier. You need the focus to sit down, shut out the noise, and actually engineer these multi-agent architectures. The tools are sitting right in front of you, but the clock is ticking. The AI revolution is moving at breakneck speed. So I'll leave you with this. Will you be the one replaced by this technology, or will you be the one building the agents? The choice is entirely yours. Thanks for joining me on this explainer. Now go out there and start coding.